Good morning, everybody in Algebra 2. Sorry I'm not able to be there today. I'm not feeling well at all. So I'm just going to make this video here. And for the substitute, all you have to do is press play and pause. I'll try to let you know verbally throughout the lesson. But let's get started. Today's lesson is lesson 8-7, and the title is Operations of Functions, and I believe the date today is 3-11. So go ahead and title your page with all of that. Okay, we'll skip the 5-minute checks and get right into the lesson. Okay, so we weren't able to fit, we're still in chapter 8, we weren't able to fit this into the unit for the test you just took on Monday. So before we were able to perform operations with polynomials. Now we're going to find the sum, difference, product, and quotient of functions. And we're also going to find the composition of functions. So please take good notes, follow along. Feel free to stop and rewind this video if I ever go too fast and you miss anything. Okay, the new vocabulary term today is composition of functions. And let's just think about what the word composition means. I'm looking at the online definition right now, and the word composition means the nature of something's ingredients or constituents, or the way in which a whole or mixture is made up. So basically the way something's made up is composition. And today you're going to see we're going to have functions made up of functions. Alright, and here is some operations that we need to get written down. So take the time to copy down this table. We have two functions, f of x and g of x, and we can add, subtract, multiply, divide them according to these rules. So please copy down these rules. I think they're pretty straightforward. If you have f plus g of x, that just equals f of x plus g of x. And here's an example. If f of x equals 2x, g of x equals negative x plus 5, all I'm doing is adding those two together and getting my solution. Subtraction, same deal. Okay, it's f minus g of x, so that's just f of x minus g of x. And here's that example. Multiplication, okay, this, we gotta make sure we have our notation. This is f times g of x. Make sure there's a huge difference. There's a reason this circle is really dark. Okay, that little dot means multiplication, because later on we're going to have a different notation that looks pretty similar to that. So make sure you're making a note that that is f times g of x. Again, that's just f of x times g of x. And division, f divided by g of x is just f of x divided by g of x. So go ahead, press pause if you have to, and copy this down. Alright, let's add two functions together. Let's just do some examples. Given f of x equals 3x squared plus 7x, and g of x equals 2x squared minus x minus 1, find f plus g of x. So if you look back at that table that you just copied down, our rule for addition is just simply f of x plus g of x. Alright, that's just your rule from the table there. And then just add them together. You guys know how to add polynomials. Okay? Add those together and simplify. So that's what you should get as an answer. I think that's pretty straightforward. Shouldn't have any problems doing that kind of stuff. There's our answer. Okay, we don't have to factor these down, by the way. You can just leave them like that. Okay, here's just another example. Don't worry about it, but try this one on your own and see which one you get. And Mr. Substitute, if you could just press pause to let the kids work on this right now. Give them a chance. And then everybody hold up a number on the count of 3 to see if you all got the same answer. And the answer is A. Alright, adding functions. Alright, this time we're going to subtract functions. We're going to take f minus g of x. So be very careful. Make sure you set this up properly and you use your parentheses so that you're not making silly mistakes. And And there's the answer. Sorry if I went a little too fast. Okay, next examples. Given f of x equals that and g of x equals that, find f times, notice how this is very filled in, it's a closed circle, f times g of x. Looking at your table, that's just f of x times g of x. Okay, really emphasizing that filled in circle. So do f of x times g of x. This is a trinomial multiplied by a binomial, so we can't use foiling, so we're just going to have to distribute. Okay, distribute the x in. It goes boink, 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 and then the negative 4 goes boink, boink, boink. After distributing, this is what you should get. And there's our answer. Okay. Another example doing division. It's just f of x divided by g of x. Pretty simple. Okay, you just fill in, you're just substituting in your values, or your expressions for f of x and g of x. Notice that's important. It's important that we have to put a constraint on our domain, because we can never divide by 0, so x cannot equal 4. Sorry about that. I had a DVD in my laptop that decided to play. Okay, so we're just dividing, and there's our answer. Just simply f of x divided by g of x. Obviously, sometimes we're going to have to simplify these, so you'd have to factor the numerator and see if you can cancel anything out in the denominator. And just make sure that the denominator can't be 0, so exclude 4 from your domain for f divided by g of x. Alright, you guys give this one a shot and press pause. The answer to this one is C, so hopefully everybody got that answer. Try another one on your own. Press pause. Oops, better make sure I get all the answers in there. Okay, it's just f of x, f divided by g of x, or f of x divided by g of x. And you should have gotten B as your answer. Alright, functions can also be combined using composition of functions. In a composition, a function is performed and then a second function is performed on the result of the first. The composition of f and g is denoted by f of g. Okay, notice now we have an open circle. That's f of g. You'll hear some teachers call that fog. Okay, f of g, open circle. That's how we're going to state that. So basically, we're finding the function of a function. That is what composition of functions is. Finding the function of a function. Alright, here is the confusing part. I think it's confusing a little bit, so make sure you're paying attention. If I have f of g of x, okay, f of g of x, or I could just put function of g of x. So if you'll notice, okay, g of x has an input of x. Right? That's its input, that's its domain, right? Domain is x values. Then whatever I get as an output of g of x actually turns into the input of f. Okay? So first we have to find g, take its output, and that becomes the input of f. And that is shown right here in this model. So please copy that down. Try to make sense of it. I think you just got to practice it in order for it to make sense. So what this is showing is kind of what I was just talking about. The domain of g, okay, the input is x, right there. You kick it out and get an output, or the range of g, which is actually equivalent to the domain of f. Alright, that becomes your new input of f. And now the range of f is f of that range of g. So whatever you got for g of x becomes your new input for f. So copy this down. If I have f of x equals these coordinates and g of x equals all those coordinates, first we have to find f of g of x, and then we'll find g of f of x. So the first thing we got to do to find f of g of x is find g of x. Okay? To find f of g, we have to evaluate g of x first. And then we're going to use the range of g, or our outputs of g, as our inputs, or domain, of f. So, g of 7. If you look at g of 7, you input 7, your x is 7, input is 7, your output is 0. So g of 7 equals 0. Now I'm taking that 0 and inputting it in for f. And then I got to look up here, what's f of 0? That's right here. F of 0 is negative 1. Okay? G of 7 equals 0. You find that's your range of g, and then you input that for the domain of f to get negative 1. Okay, now just find g, so I'm just going in order, okay? At g of x equals boink, 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 boink. Okay, I'm just finding g of my input, or my x value. So g of negative 1 is 7, f of 7 equals 7. Next up we have g of 4, g of 4 is 9, f of 9 equals 4. G of 8 is 2, f of 2 equals 6. So that's what our answer would look like. F of g. Our input in the first one was 7, and our output was, so we took g of 7, and our output was negative 1. Then our input became 7, or our input, excuse me, was negative 1, and our output was 7, so that's where you get negative 1, 7. We input 4, our output was 4, so that's where 4, 4 comes from. And then we input 8, output 6, so that's where 8, 6 comes from. Alright, kind of tricky, it takes practice. Now we're going to find g of f of that same function. So now instead of finding g first, I'm going to find f first, or f of x first. So it's the same thing, just the other way around. Okay? Looking back at that example, f of 2 was 6, so g of 6 is actually undefined. Okay, we don't have a 6 in the domain of f. So g of 6 is undefined. Then find f of 9. Okay, f of 9 equals 4. Input 4 into g, your output is 9. F of 7 is 7, and then take g of 7 to get 0. F of 0 is negative 1, g of negative 1 is 7. So since 6 is not in the domain of g, g of f is undefined for x equals 2. And then here's our answer. Okay. Input 9, output 9. Input 7, output 0, input 0, output 7. Okay, let's just try one on your own. Okay, you guys try this one, press pause, talk with your neighbor, see what you get. Alright, feel free to talk it out with your neighbors, partners. Okay, work through this together. You get an answer of A. Okay. This is actually going to conclude my first video. I can only make it 15 minutes long. So I'll get the next video set up. Might need to help each other out with the technology. So peace out.